everyone, thank you for joining. This is the Oracle Machine Learning office hours. Today we have the OML usage highlight, a live demo of Oracle Stream Analytics with OML AutoML UI and OML Services. And this is going to be presented by Hadi Javaherian, a solution engineer on the AppDev and integration team. And myself, Marcus Arencibia, and Mark Hornick and Shari are going to be supporting. So anytime you guys have any questions, please feel free to write that in the Q&A. Basically, the topics for today are we're going to be just highlight a few upcoming sessions, and then we're going to talk about the session. And then at the end, we're going to work with the Q&A. So these are the upcoming sessions, just to give you an idea. So for next week, we're planning on an OML for Pi updated hands-on lab. We're still working on the details that might slip. And if that happens, we're going to probably see it in October at some point. But the idea then is for October 5th, using third-party Python packages from Python, SQL, and REST. Then on October 12th, a time series analysis. And then November 2nd, a weekly session. November 9th, a leverage OML algorithms in retail science platform. So without further ado, I'll give it up to Hadi. Thank you very much, Hadi, for joining us today. And the floor is yours.
Great. Thanks so much, Marcos and Mark, for the invitation. So today, I've been working with these two products, GoldenGate Stream Analytics and OML for a while now. And what I came up with this scenario where we could integrate these two products in a very nice, low code, no code as far as the OML part is concerned, into one sort of a scenario use case, and show you this in the demo. And before I do that, I wanted to kind of show you how this sort of applies to the general idea of data mesh and data fabric and data product. And so this is something that's been getting a lot of attention recently in the industry. And here at the Oracle, we're really focused on this idea. And in the forums, obviously, we're getting a lot of attention and recognition from Forrester, Gartner. As you can see, Oracle is a leader in this space. ThoughtWorks also has given us a lot of recognition there. And so variety of sort of forums have recognized that Oracle is a leader in this space. So what I wanted to do is I wanted to start with the idea of data product and sort of a data capital, where we really need to look at the data as a sort of a capital, not a mineral, oil, or gas that you can actually mine out there, but it's something that to be created and then used as by the consumers. So think of data product as a sort of a, something that it's not a product, but it's a byproduct. And so in a data mesh kind of a thinking, in a data product kind of a thinking, data mesh is a sort of a data tier architecture that you can say is to integrate data assets and data products across multiple cloud environments. And there's a lot of definitions for these two terms, data mesh and data fabric, to sort of interchangeable, but it depends on how you look at it. It's been sort of out in the industry, and it's getting a lot of attention. And so some of the attributes of that in a data mesh environment, you have to have a decentralized environment, right? It has to be so it can be used in a multi-cloud, right? And then the second feature of that would be event ledgers. Events that could be at the edge from IoT sensors, or it could be transactional, if any kind of a transactional kind of a source that comes into a data mesh. And of course, it has to be has some polyglot sort of features. It has to be multiple formats. But when it comes to the consumer doesn't care what format that is. It could be in JSON, it could be in REST, in any kind of a format that the consumer kind of uses that. And then in terms of data ledgers, we sort of look at two sets of data. One would be a sort of a trail file that comes in in GoldenGate, and the other one would be IoT type data that comes in sort of as a Kafka source. And in terms of data products, obviously, we start with the variety of data that comes in, order, checkout, cart. This kind of data comes in basically 24/7 nonstop. Some of it is noise. That data gets sort of transformed a little bit and then sort of, kind of refined. And it comes up to the top, becomes a data product, when it actually gets used by the consumers, right? So the variety of data products, one of the examples would be machine learning feature. The other one would be a machine learning model, would be a type of a data product. And there's other types of data products, but in this case, we want to focus on specific in machine learning and machine models and sort of stream analytics. Again, as I mentioned, in a data mesh, it has to be decentralized, not like hub and spoke type model. You really need to adopt a decentralized event processing model, such as, let's say, a locomotive that sends thousands of sensor data points to the server, and this raw data at the source comes in. It helps create the data product through this data mesh architecture to be consumed by the consumers, right? So you can think of the source data, right, raw data, and then the target data, basically refined data ready to be used. Or you can look at it as operational data that comes in versus analytical data. So this is sort of a source and target type definitions. And again, in a data mesh, as you can see, this diagram looks a little bit too busy, but then these variety of use cases that apply. You can, a Tesla car has, thousands of sensor data that comes in. That data comes to the edge and gateways. It gets filtered, and then you can process that through stream analytics. And also in a data pipeline, what we define a data pipeline, you really need that data pipeline to be prepared when it comes as raw data. It needs to be prepared and curated in a type of data mesh environment. As you can see, there's a sort of a data lake there. And data mesh sort of curates that data and then sends that data to the final targets in a variety of formats, right? One of them would be a notebook in machine learning or a machine learning model that'll show you that how easy it is to create that through these OML services and be able to consume that. In a stream analytics itself, you have a variety of data sources that come in formats like GoldenGate, Kafka, and JMS, any kind of a format. That data gets ingested into the stream analytics, right? And then we have these rich set of patterns that we apply to this data, right? And I'll show you a little bit of that in the demo. Once you apply these patterns, then what we call the sort of the highlight of stream analytics is a pipeline where you create this pipeline and run some analytics on it, machine learning in this particular case. We're going to use AutoML. And then once you're done with your analysis and so on, send that data downstream to a variety of targets. To send that data to object storage, MongoDB, Ignite, Apache, Ignite, Hive, S3, and so on. And I'll show you a little bit of that. And again, in terms of data products, there's a variety of data products, and this sort of covers a little bit of that. You may have a dashboard where your consumer or your end sort of analysis needs to have some kind of a dashboard showing some data, right? That's one data product. The other one would be a time series, spatial and analytics. They can apply to a sort of a bandwidth of data set, and you're interested in that particular bandwidth, right? Or in the top middle, in that pipeline, we are basically using this no-code pipeline throughout the entire sort of a live streaming of live data and creating what we call these stages. And these stages, I'll show you a little bit, are themselves can be considered a type of data product. And of course, top right corner is we're applying machine learning to the data set and you being able to use that. Onyx is coming up as far as the stream analytics, but you can actually call an Onyx model. But in this particular case, I'm going to show you how easy it is to use AutoML UI to actually be able to create a model and use it. And again, the AutoML UI is obviously a kind of a familiar slide to OML users, but there's a pipeline of series of sequences that happens. You start with an algorithm selection, you do some sampling to the algorithm, do some feature selection, very important in a machine learning concept, feature selection, and the tuning of that model. Again, all this is seamlessly done behind the scene for you through AutoML UI, which is really sort of has caught my attention, for this specific use case, and I decided to kind of marriage that with stream analytics. In terms of architecture in the stream analytics, you're looking at two types of pipelines. One pipeline starts with a raw data set. That raw data set, an initial data set that you have that comes in, you basically need to enrich that data set. Whatever you need to do, add some derived features, or if you can manage the balancing of the data set, right? Do something with that data set through a pipeline in stream analytics. Then send that pipeline as a target to autonomous. And I'm going to show you how I will switch to my autonomous UI, generate that model, create a model, deploy that as OML services, and go back to stream analytics, create another pipeline. That pipeline is going to be a consumer of my data products, that data product being the model that I just generated, right? And in the meantime, during that pipeline itself, create more data products, right? So start with sort of raw data, Kafka, JMS, GoldenGate as data feed, prepare that data, again, in actual use case, process it. When it comes time, call some REST API call to OML services, the model that I just generated a few minutes ago, right? And apply additional patterns, statistics, whatever you need to do, process that data and send it downstream to your target for it to be consumed, right? And again, remember that original slide with the sort of a busy data mesh architecture. This is sort of the architecture specific to this particular use case. And the use case is that we have a scenario where our customer is a company that owns and runs vending machines all around the world, right? These vending machines send data at the edge through IoT sensors, right? And based on that data, we would like to predict when these machines are likely to malfunction, specifically run hot or any other errors, or run out of stock, right? So that's the prediction where machine learning comes in. So my raw data comes here and on the top left, right? Into stream analytics, I massage that data, curate it, I prepare that data, and create a training pipeline. Once I'm done, happy with my data set, I'm going to set that training data to autonomous, so AutoML. Go to AutoML, quickly generate a model, deploy it, come back to stream analytics as I showed in the architecture, create another pipeline, and use that model in the scoring, right? Once I'm done with the scoring in this particular use case, I send that data to my final target. That final target could be object storage, could be a data lake, could be a variety of targets. As you can see, these targets are all supported there. And in this particular use case, it's going to be Apache Kafka, where my maintenance team, the company's maintenance team, taps into that Kafka topic, gets that data, goes to the site, maintains the machine, whatever it is, or another team can go and stop the machine, maybe two separate teams, right? Once they are done, that maintenance record again gets uploaded to the stream analytics and then gets ready for the next cycle, right? So this is sort of ongoing, real-time, sort of in a data mesh kind of environment, right? So let me switch quickly to, basically in stream analytics, there's a variety of references or resources that we use. The main one being a pipeline. I have these pipelines defined here. I'm going to basically in this particular pipeline, what I did is I started with, again, these bubbles each represent a stage. And at this stage, if I click on one of these stages, you'll see that the data for that particular stage just shows up, nothing else, right? So it's pretty impressive. Live streaming data. My machine sensors are sending data. Basically, I capture that data, I curate it, I prepare it with some machine details, machine ID, where they're located, and so on. And in this stage, they're prepared, right? As you can see, each stage has its own set of data as they come in, right? I prepare that data. Once I'm happy with that data, again, this is a little bit too simplistic pipeline, but you can imagine you can get very elaborate with this. And once I'm ready, I send that data to my final target. In this particular case, my target is autonomous, and I have two separate tables there, right? One that keeps track of how many days it takes for this machine to run hot, right? And prediction, it's sort of a prediction. The other one would be another table where how many days will it take for this particular machine to run low on inventory, right? So two sets of targets. I send that data to my target. Then I quickly switch to see how quickly that was, and I quickly go to my autonomous. I go on AutoML, right? I create a model in AutoML, right? And again, in here I can define data source, and I'll go through this a little bit quickly. I go through this data. Not how many days it will take for it to the machine to start hot, right? This is the data set that I exported to autonomous, right? And then I define what my target looks like, how many days, and my sort of case ID will be my machine ID. And then I run a regression sort of type model, right, through the training. And I start this, and in a matter of minutes, I have a model. So I'm not going to do this again because I have some models prepared here. I go to my model screen. These, as you can see, these models are already done here for me. Again, the days that are running high, how many days before they run, the machines run into high temperature. And the model the AutoML gave me 5 choices. Pretty impressive, right? And I've kind of sort of tested these. They look really good. I picked the support vector machine model for my use case, right? And I clicked on it and I deployed it. And now I have a model here, right? Deployed in OML services, ready to be used, right? So SVMG not cooling and then low inventory, right? So that's ready to be used. I switch back to my stream analytics, create another pipeline. In this pipeline, again, remember from the diagram, from the slide, my maintenance team continuously giving me data, right? That is getting updated, right? And my machine sensor data, it comes in. I again enrich this in this pipeline. I create this stage that with this set of fields that I didn't have before, right? I do a correlation here, and if here I start with 10 fields, here I probably end up with like 20, 30 fields because I need that for my analysis, right? And then 2 separate models. One model, I call this model that is, how many days before the machine starts running hot, right? And again, all I do here is define where my autonomous is. Remember this model name that I used? I specify that, and I'm done. Basically, I go to these, to my final analysis or a stage. After I run more analysis on this, as you can see here, it says it's scoring, right? If I go here, I have some scoring data, right? Scoring data. These are actually, these are number of days, right? And as you can see here, this particular machine needs to be replenished because it's running low in inventory, right? It's as sort of a prediction. So I send my maintenance team to the machine to maintain that. Same thing for my machine running too hot, right? I send a maintenance state. Again, here, this stage shows, do I need to send the maintenance today? Or if the machines are, if obviously if the machines are running too hot today, I basically send that today. But if the machines are normal cooling, I want to be prepared, proactive, right? I want to know in how many days are my machines going to be running hot, possibly, right? And in this particular day, it's April of 2022, this particular machine shows that it might be running hot and proactively send maintenance team. Again, we have a variety of, in this tool, you apply filters, you apply visualizations to the data. It's a rich set of patterns here that you can use with these pipelines. As you can see, variety of statistics, ready out of the box for you that you can apply to your model. And if I go back to the catalog, you can define a variety of targets, variety of streams of types of data that to ingest, variety of these targets. As you can see here, I have Kafka target, object storage, REST, S3, and so on. So it's a rich set of resources that you apply to your model when the data is streaming live. And again, this particular use case is kind of it was very interesting to me. That's why I decided to put it together. And I presented this to both the OML team and the Stream Analytics team, and really with positive feedback. So again, I'll stop maybe here, Marcos, and see if there are any questions I can answer.
Sure, that's perfect. Thanks a lot, Hadi. So one of the questions that we just got was, can real-time dashboards alerting be utilized out of the box in OAC? That's the Oracle Analytics Cloud. I believe you can, right? Because that's a pull interface, but I'm not sure if you have other comments.
Right,
there.
because but your data needs to go to the database, right? And then OAC can actually, yes. And that's one of the use cases actually we're putting together for another demo. But data has to go to database, yes.
Okay, makes sense. So we have a question. How do you envision the governance to allow data consumers to search for and subscribe to data products in the mesh?
The governance, right. So basically, as data comes in, right, the raw data as it comes in, obviously we have no governance over that, right? This data comes in through a variety of sources, right? Cart, checkout, order, these data keep coming in. Tesla keeps sending data regardless of what we do with it, right? But governance comes when you're applying data mesh architecture and data fabric architecture to it. That's where the governance comes in. And of course, definitely at the target, when you're defining your data product. So again, sort of the sequence of events is that you basically start with your data products, right? Your data products are getting defined. How do you want to consume these? How do you want to show this? And then you go to the data mesh and sort of create that architecture, then apply the data mesh to the sources. Again, the governance doesn't apply to the source, obviously, right? Because sources are coming in. Right? I don't know if I answered that correctly or the way you were looking for.
Yeah, thank you.
Sure. And then so the other one would be, while I'm on this diagram, specifically to machine learning, you have what we call a derived features. You have a set of raw data that comes in. Some of those features in that data set is not usable, right? You have to create some derived features. So that's part of the data preparation. And again, there's a concept of imbalanced data set in a machine learning type environment. Once you recognize that, you can actually possibly balance that data set before you actually send it to training, right? So these are some of the great, sort of use cases that you can do before before you generate your model.
Another question is, does the pipeline support both ONNX and PMML formats?
PMML format, yes. ONNX is on the roadmap for the Stream Analytics team. That's the next one that's coming out. Once you create your ONNX and with the, Sherry has shared some use cases that shows how you can create a ONNX model. but that's coming up, yes. But PMML is already there.
Mm-hmm. Yeah, and in the case of Onyx, I mean, I would also add that the OML services support Onyx, right? So if you have an Onyx model, then the OML services can serve that as a REST to OSA, right? So then you can actually use an Onyx model from OML services, just like you're using today as an integration, right? That you're showing, just not directly inside, I guess, the
exactly. Yeah,
right?
that's a good point, Marco. So so the difference between that, for instance, like PMML, it's already supported. What you would have to do is you would have to go and create a PMML model somewhere else, right? Using another tool and something like that. You know, your data science, create that model, and then that model is ready as a PMML format in your pipeline. Call that model. Mm-hmm. This particular use case that I just shared is sort of is kind of really at your fingertips, where you basically once you have a training data set, once you've created a training data set, you can use AutoML, quickly generate your model on the fly, basically, you know, more or less, right? With the, you know, on the AutoML UI part of it, there's actually no code involved. That's really impressive to me, at least. And then you can go back, create another pipeline. So that's what sort of attracted me to this particular use case, because it's really right there, and with little effort, you can actually be able to use the model.
Mm-hmm. Awesome. Another question we have here is, since training pipeline uses real-time data, are there adequate number of training samples? How frequently the model is retrained for new events?
You can, well, maybe I'll let you guys, maybe Marcos answer that, but basically, if you can create a variety of pipelines, right? So basically, if I go back to this data set, right, to this pipeline, right, I can create a variety of, as long as these, you know, I have separate tables there, because in OML, basically these are in database sort of machine learning, you know, model creation, right? So as long as I define the variety of tables, I can create this pipeline as fancy as I like to. Tomorrow, I can create another target here, add a stage, go to my pattern, you know, and not in, but go to my target, right? Create a target, and define that target, and that target could be another OML autonomous database table, and basically apply it again. I think that's probably the best way I would do it. I don't know if I answered that the way you were looking for.
Right. No, and I think he was asking about the probably more related to the statistical nature of data, right? So is that normally when you want to build a model, you have to have enough data to build a model so that the model can find patterns, right? If you have only like the last 100 records coming in, then all the patterns throughout the day are not going to be there. So I would say mostly you probably want to create a model with the larger data sets, right, in batch, and then potentially add the latest data, right, to that model. I wouldn't build a model completely on brand new data that is coming in, because you're really, you know, throwing away all the history that is probably important and rich, especially in seasonality, right? So for seasonal products and things like that. So I think that would, you know, I would actually add that data and either refresh the model or have a moving window where you can move to the future and say, okay, I throw away data from, you know, the last day, the oldest day, and then I'm now feeding in new data from today or something like that. But that was for building the model case. Not really that just...
That's a great scenario itself, Marcos. As you can see here, what you were saying is that this machine details could be some rich set of data set, right? That very basically can define my training and data set. And then I can, on the fly, add this sort of streaming data to enrich that, right? Before I send that to training. I think that's a great use case for itself, yeah.
Right. That's exactly.
I like that, yeah.
Then another question that I think it's more on us is how many different OCI machine learning services available on Oracle Cloud? I know about Oracle Machine Learning Service. Are there any other services for of ML and AI? Well, Sonali, there are. Oracle has the Oracle Machine Learning, so that is us, right? The team that you're talking to today, which is the in-database algorithms, right? We are running on inside Autonomous Database, inside Oracle Database on-premise. You have the OCI Data Science team that has a specific service for Jupyter notebooks, and then they run Python. So if you're looking for open source tools and open source Python components, that's where you would find probably the most rich environment, because they also have GPUs and things like that that are for Python. And then Oracle is launching several different AI services now, right? So we have an AI language service, a vision is coming up. So those are REST services that you can just call from within your application for a specific, vision or language or some other process. So those are different components that Oracle gives you so that you can have, the most amount of tools available, let's say, right, for your projects. Hopefully that answered the question. There's one other question here. What is the minimum configuration requirements for OSA?
Really, that you don't need that much configuration. In OSA, typically, if I click on all these resources, right? Basically, what you do is you come up with a stream of data, right? You define your stream of data, what live data you want to process, and then basically a connection to what it is that you want to. Do you want to connect to a GoldenGate trail file? Do you want to connect to the Oracle database or MySQL? Or do you want to tap into local Kafka, right? You define these things, very easy to use. One of the scenarios that we have a customer, a retail customer that literally they brought in interns from university, right out of the university, and in a matter of 2 weeks, without previous knowledge of this tool, they put together a really elaborate pipeline. Our customer was very impressed. Our team was very impressed how these two interns quickly did this. Very easy to use, very user-friendly. In a matter of minutes, you can actually create a pipeline. Once you have all these, your resources sort of lined up, if you know where your, where your autonomous is, let's say where your HDFS is. And so on. But very easy to use. And again, AutoML itself too. They're both so easy to use. Yeah.
Excellent. Another question here is, for streams of data, we would need a data source to send data continuously row by row. How could we simulate that if we want to do a POC?
Very simple. CSV files. Yeah, CSV files are a great way to create a stream of data. And in fact, some of this simulation that I've done is actually uses CSV files. Unless you have actual GoldenGate streams, trail files, or Kafka topics that you want to process, CSV files are a great way to do this. You can create these streams with CSV files. Yeah, very, very easy to use.
Well, I think we have no more specific questions. So I would like to say just thank you very much, Hadi, for your session. It was very, very, very interesting and very interactive, and I think people got a lot out of it. And really just thank you, and really appreciate you for joining, and thank you guys, and talk to you guys next week.
Thanks so much, Marcus. Appreciate it.
Thank you.